one last video for this semester, whole semester, which is percent composition. And percent composition is an application that we're going to use second semester. So we're going to learn kind of the foundation of the math now, and then we'll apply it later on to your empirical formula and your molecular formula, things like that, as we move throughout the second semester. So when you're looking at your percent composition, it has to do with how much of a compound is made up of certain elements by mass. So we know that if we have like H2O, water, we have 2 hydrogens and 1 oxygen, and that's a 2-to-1 ratio. Well, this is by mass. So we know that hydrogen has a mass of 1.01. 1.01 is very, very, very tiny. It's actually the smallest molecular mass of anything on the periodic table, whereas the other component in water is oxygen. Oxygen has a mass of 16. So when we're looking at that size to mass ratio there, the majority of your compound is made up of oxygen by mass, not hydrogen. So even though there's more hydrogen there, we want to know what percentage of the molecule itself is made up of hydrogen versus oxygen. So your percent composition is finding the percent by mass of each of whatever elements it's asking for in your compound. Sometimes it might say just one of the elements. It might say all of the elements. The example that I'm going to give you guys is using all of the different elements in the particular compound that we're dealing with, but it might just ask for one. So with your percent composition, we are looking at the percent by mass. So when we're finding a percentage, it's a part divided by the whole. Anytime you find a percentage, part divided by the whole. So the part that goes on top is your total element mass. If you have 2 hydrogens, it's the total mass of your hydrogens. And then the total compound mass is your molar mass. So you take your part divided by your whole, your element mass divided by your molar mass, times 100 because it's a percentage. And then the unit, like it says down here, is percent. If it asks you just for one of the elements in the compound, you would just do this one time. You might have to do this for different elements that are in the compound itself. So you kind of have to look at it by a piece-by-piece basis, depending on what the problem says. So this example that I gave you, it says find the percent composition for each element in lead-2 nitrate. So with this one, we're going to have to find the formula first, because we don't have a formula. Then we find the molar mass. Then we're going to find the different elements that are there. So we're actually going to do 3 different problems here. One for lead, one for nitrogen, one for oxygen. And we want to know in the elements, in the compound as a whole, how much of that mass comes from each of the different elements that are in the formula. So I'm going to switch over to my document camera here. Sorry. Let me make this just a little bit bigger. There we go. So in the example that I have, it says find the percent composition of each element in lead-2 nitrate. I need a formula. Lead-2, this 2 means that lead has a +2 charge. Nitrate, ATE, is NO3 minus 1. So we're going to swap and drop, and we end up with Pb, NO3 with a 2. Now, I need to find the molar mass. So to find the molar mass, I'm going to look up each different element on the periodic table and add them together. I'm going to hold that all in my calculator, though, just to make my life a little bit easier. So lead, when you look it up on the periodic table, is right here. It's kind of behind my picture, sorry. But it's 207.2. There's only one of them. Plus, I have 2 nitrogen. So 2 times 14.01. Remember, molar mass always has 2 decimal places. Plus, I have 6 oxygen. So 6 times 16. My molar mass of this whole compound, I'm going to put MM, is equal to 331.22 grams, and that's the mass of 1 mole. This is the only real part that I need to focus in on right now. We're going to deal with that mole later on next semester. So I'm going to do 3 different problems. One of them, I'm going to figure out how much lead by mass is in my compound. I'm going to figure out my nitrogen, and I'm going to figure out my oxygen. Now, when I do each of these, the bottom number is my molar mass, 331.22 grams. For the top number, I need to find out the total mass of lead. Lead on the periodic table is 207.2 grams, and there's only one of them, so I just have that one time. In my formula here, I have 2 nitrogens. So I'm going to take 2 times 14.01, kind of got crazy with my 4. And then my oxygen, I have 6 times 16. So this one is 28.02 grams divided by 331.22. 6 times 16, 96 grams divided by 331.22 grams. And then in each case, I'm going to multiply times 100 to get my answer. So I kind of did all 3 problems together at the same time just because it was a little bit faster. Again, if they were only asking for what percent composition is this of nitrogen, we would only do this problem. You don't always have to do all 3 problems. So this one we're going to take 207.2 divided by 331.22 times 100. Now sig figs. 100 is not a measurement, it's an exact amount. So I have to look here, I'm dividing. I'm going to use the least amount of decimal places. Sig figs as my input numbers. So 1, 2, 3, 4, 1, 2, 3, 4, 5. My answer can only have 4 sig figs. So 62.56%. The next one, 28.02 divided by 331.22. Again, 4 sig figs, 5 sig figs. I can only have 4 sig figs in my answer. So 8.4, 1, 2, 3, 60%. Nope. $59. I didn't round right. I looked at the wrong number next door. 1, 2, 3. No, I did that right. Oh my goodness. 8.45. I did it again. 60. I had it right the first time. I'm sorry. 8.460%. Sorry, it's been a long day. I was thinking that there was a 9 next door to the other 9. So 8.460. Now the last one down here, we have 96 divided by 331.22. Again, we have 4 sig figs in this answer. What in the world did I do? 36 divided by 331.22. Oh, I hit divide by. So times 100, you get 28.98%. So looking at this by mass, the majority of the compound is coming from lead. Then you have your oxygens, and then your nitrogens are last. So the majority of it comes from the mass of the lead, which makes sense because you have 1 lead and has a mass of 207.2. When you're looking at these, if you're finding all of the elements, when you add these together, you should be about 100, which we're about in that range, so that would make sense. And you always, when you get your answers on these, are going to be less than 100%. So if you run an answer and you get an answer of like 212%, you're wrong. So just make sure that you kind of get numbers that make sense. On your practice problems, you're going to have to show your work. When you show your work, you really only have to start with right here with this step. When I ask you to show your work, that's what you need to write down right there. I know the equations, so equations aren't showing your work. I need to see where the number's getting plugged in. This part, if you want to just write this, you can do just that, and you can actually plop it in your calculator exactly like this without writing this next step. I just need to know what numbers are you placing where. You need to use sig figs for your answer. So remember, you're looking here. Ignore the 100 because that's not a measurement. And then your unit is percent. If you guys have any questions, be sure that you ask. Otherwise, this was it for the semester. So when we come back, we're going to do mole conversion, stoichiometry, and we're going to keep rolling through the math. I hope you guys have a great day.